With billions of potentially habitable planets scattered across our galaxy, one deeply unsettling theory suggests the silence we hear from the stars might not be an accident, but evidence of something that stops nearly every civilization before it ever reaches us. The Great Filter is a theoretical concept proposed to explain the apparent absence of detectable alien civilizations throughout the universe. This theory was formally introduced by economist Robin Hanson in 1996, building directly upon the earlier Fermi paradox. The Fermi paradox, named after physicist Enrico Fermi, questions why, given the universe's vast size and age, we haven't detected any alien signals. Given billions of years of cosmic history and countless potentially habitable planets, statistically, intelligent life should be relatively common. Yet despite decades of dedicated searching, humanity has found absolutely no confirmed evidence of any other civilization anywhere in the universe. The Great Filter theory proposes that somewhere along the path from lifeless chemistry to advanced, spacefaring civilization, an extremely difficult barrier exists. This barrier, or filter, prevents the vast majority of potential civilizations from ever reaching a detectable, advanced technological stage. The theory doesn't specify exactly where this filter occurs, only that logically, some extremely improbable step must exist somewhere along the path. This creates a genuinely unsettling question for humanity. Has our own civilization already safely passed through the Great Filter, or does it still lie ahead? If the filter lies behind us, in our evolutionary past, this would actually be extremely good news for humanity's long-term future prospects. This would mean the difficult step already occurred, perhaps involving the origin of life itself, or the evolution of complex, intelligent life. Some scientists propose that the very origin of life, transforming simple chemistry into genuine, self-replicating biology, might represent this rare filter. If abiogenesis, the spontaneous emergence of life, is extraordinarily rare, this could easily explain why so few civilizations ever develop anywhere. Others propose the crucial filter might be the specific evolutionary jump from simple, single-celled life to complex, multicellular organisms. On Earth, simple life existed for billions of years before complex, multicellular life finally evolved, suggesting this transition might be genuinely difficult. If either of these early filters already lies safely behind humanity, this would be profoundly reassuring for our species' long-term survival prospects. However, a far more troubling possibility exists, that the Great Filter lies ahead of us, still waiting to be encountered in our future. Under this scenario, civilizations might commonly develop intelligence and technology, only to inevitably destroy themselves shortly afterward. This would mean numerous other civilizations may have existed throughout galactic history, each eventually succumbing to the same catastrophic filter. Scientists have proposed several potential candidates for what this forward-looking, existential filter might actually represent. Nuclear weapons represent one commonly proposed candidate, given their capacity for near-total civilizational destruction within a very short time frame. Since developing nuclear technology in the 20th century, humanity has possessed the technical capability to destroy itself entirely. Some researchers propose that advanced artificial intelligence could represent another potential existential filter facing developing civilizations. An uncontrolled or misaligned superintelligent AI system could theoretically pose catastrophic risks to its creating civilization's continued survival. Climate change and environmental collapse represent additional proposed filters, as advancing civilizations may consistently damage their own habitability. Some theorists propose that resource depletion, following industrial development, might commonly prevent civilizations from achieving long-term sustainability. Pandemics, whether natural or artificially engineered, represent another potential catastrophic risk that could plausibly eliminate developing civilizations. Some scientists have proposed that self-replicating technology, like advanced nanotechnology, could pose unpredictable, potentially catastrophic risks. The Great Filter theory doesn't require a single, universal cause. Different civilizations might succumb to entirely different specific challenges. What matters for the theory is simply that, cumulatively, some combination of challenges reliably prevents most civilizations from becoming detectable. This sobering framework has directly influenced serious academic and philosophical discussions regarding humanity's own long-term existential risks. Organizations dedicated to studying existential risk, including several prominent university research institutes, directly draw upon great filter concepts. These researchers argue that understanding potential filters ahead could help humanity actively avoid succumbing to similar catastrophic outcomes. Some scientists find a strange, cautious comfort in the great filter theory, viewing the universe's silence as motivation for careful, deliberate action. If humanity understands the potential dangers ahead, we might successfully navigate past them, unlike other civilizations that potentially failed before us. Other researchers propose alternative, less alarming explanations for the observed cosmic silence, avoiding the great filter's troubling implications. Some suggest civilizations might simply choose to remain quiet deliberately, avoiding detectable radio transmissions for unknown strategic reasons. Others propose that truly advanced civilizations might communicate using methods currently completely undetectable by human technology. Some researchers argue that interstellar distances alone might make detection genuinely difficult, regardless of how common civilizations actually are. Despite these alternative, less alarming explanations, the Great Filter remains one of the most discussed and debated resolutions to the Fermi paradox. The theory's genuine power lies in its direct, uncomfortable relevance to humanity's own uncertain, unfolding technological future. Unlike purely abstract astronomical mysteries, the Great Filter carries immediate, tangible implications for decisions humanity makes today. A multiplanetary species facing a single catastrophic event affecting one planet would still retain populations safely surviving elsewhere. Whether the Great Filter lies safely behind us in our evolutionary past, or still waits somewhere ahead in our uncertain future, the silence of the universe remains one of humanity's most profound and unsettling questions, one that may ultimately depend entirely on the choices we make next.